Hello, everyone. Welcome to my final presentation for the class of Intro to Material Science. My name is Gustavo Pulido Molina, and the concept that I will be focusing out of the class was the face-centered cubic structures, a material that we cover on chapter 3. And the bulk of the presentation will be focused also on how to calculate the atomic packing factor for this crystal structure. Go to the next slide. So here I put a link to the 3D model that I create. I don't know if it will work from another computer, but on the right side of the screen, I kind of open it so you guys can see the 3D model, and it'll be really helpful to support my explanation of how to calculate atomic packing factor. I created it in Tinkercad, and it definitely was a good learning experience to have under your belt. I created this slide to support my explanation as well as I'm explaining on the right with the 3D model. So what is atomic packing factor? To begin with, atomic packing factor is the volume of atoms in one unit cell per volume of unit cell. As you guys can see, there is some holes between the atoms on this FCC structure. And the formula for atomic packing factor is going to be atoms per unit cell times volumes per atom and volumes per unit cell. I break this down in these three pieces to make our life easier and easier the process of explanation. And then once we got all the results, we can plug them into the original formula and achieve our goal. Atoms per unit cells to begin with is, as we can see, there is 6 faces to this cube. And each of them have a face in the center, which is half of a sphere. So we can multiply 6 times 1/2 and we'll get 3 atoms, considering an atom is an entire sphere. Also, we can see that we have 1/8 of a sphere on each corner of the cubic structure to make a total of 4 on the top and 4 on the bottom for a total of 8. If we multiply that times 1/8 of a sphere, we get a volume of the total sphere, which is 1 atom. We add it to the other 3 atoms, and we'll get a total of 4 atoms. To get the volume per unit cell is, as it says, it's a cubic structure. So each side, we call it A, but it doesn't necessarily have to be called A. The point is that the volume of a cube is 1 side to the power of 3. Once we get that, we can plug that into the formula as well. Then the harder part of the formula is we have the volume, and the volume that we're going to use for this problem is the volume of a sphere, which is 4/3 pi r to q. The problem is that we don't know r, so we have to figure it out. This is when the 3D model is going to become handy, because if we see that if we make a diagonal from this top left corner to this bottom right corner, we can see that there is 4 radius. 1 on the top left, the face which have 2 radius, and the bottom right have also another radius to make a total of 4 radius. And if we apply Pythagorean theorem, we get that that is equal to a square root of 2a. If we want to solve for r, we just divide 4 on both sides and we get square root of 2 times a over 4. We plug that into the volume of an sphere and all together into the formula for atomic packing factor. And then in order to get a real number out of this, the only thing that it would change is actually the size of the cubic structure, how much the length is, this the number of a. So we got that the maximum achievable for cubic structures is actually 0.74, which is quite high, and is achievable by the face-centered cubic structure. So the next portion of the presentation, I hope that helps to understand a little bit better the atomic packing factor calculation for an FCC structure. So I also wanted to bring some materials and uses of face-centered cubic structure materials or elements, and some of them are very well known, and I tried to do some research on some of them. So we got aluminum, which is pretty much everywhere. We have in construction, of course, airplanes and boats. I just picked this as an example, but we all know that aluminum is everywhere in our society. We have copper, which is due to its conductive properties, is used in electrical wiring and cables. Gold for electronics. For this one, we'll know that gold is actually used more for jewelry than for anything, but I actually find very interesting that it's used on electronics as well. Then lead is used for car batteries and other kinds of batteries, but this one, due to his due to being harmful for the human being, is trying to be reduced and is trying to be very, very, very careful with this material. We also have platinum, which is used for catalytic converters for cars, and silver, which I found is very interesting because silver is essential for the manufacture of mirrors, which is actually something I didn't know, but that I just realized by doing the research for this final project. So all these materials, I introduced some of them. On the top left right here, we have the wires of copper, we have gold on electronics, and we have the catalytic converters made out of platinum and other materials. So I hope this presentation was helpful for everybody to understand a little bit better about the face-centered qubit structures. And hopefully at this point in class, we'll play this presentation and I'll be able to take some questions. So I'll be happy to try to answer them. And thank you so much for your time. I appreciate it.